Today, we're going to be talking about our operationalizing artificial intelligence. But before we get into that, let me tell you a little bit about who I am, who we are at E3S, and give you a layout of what it is that we'll be talking about. End-to-End Enterprise Solutions, we're an advanced tech company mainly focused on answering complex problems for the federal and commercial spaces. Some of those problems that we decided to put our focus in on and answer includes artificial intelligence and things like cybersecurity. But specifically, in today's agenda, we're going to be talking about operationalizing AI. And in order to do that, we'll first be going over defining what AI is, what operational AI is, the digital twin aspect of bringing it into operational AI, and then actually giving you a demonstration of what it is that we've done at End-to-End Enterprise Solutions. As we get into that, let me tell you a little bit about who I am. As I mentioned, my name is Carlton Harris. I'm the Senior Vice President and Chief Growth Officer here at End-to-End Enterprise Solutions. And I get the privilege of really getting to see the advanced tech capabilities that we're actually taking out to our customers. But I haven't always, I actually came from the background of within the Navy, actually answering to some of the complex problems that we look to strive with AI, but doing it as the human. And part of my team that's actually supporting me, we all came and had very similar backgrounds where we all started as seaman recruits within the Navy and actually operating in E3S under different titles. Kevin Dunlop, our business director, as well as Mark Walker, our director of AI and autonomous operations. We all have that past experience of actually fighting fires on board ships, being part of a damage control team. As I begin to tell you a little bit about operational AI, I'm going to commonly go back. I'm commonly going to use real world examples that we actually had experienced and seen today. One being when the Bonnie caught on fire in San Diego a few years ago, we completely lost a capital level ship. And not only that, within recent studies, GAO has came out and identified where we've lost 2 ships and over $4 billion of damage. Whenever we first seen the Bonnie, on the Bonnie catch on fire, our business director came to us and be like, "Hey, we looked at to solve advanced problems for the federal government, and this is a problem that we can solve with AI." So myself and as well as our AI SME, we put our heads together and how would we actually solve this problem if we're able to develop a solution in order to make sure that something like this never happens again. And that's exactly what we did. Recently, GAO came out with this report, and when we was looking at the 3 examples that GAO had given and the Navy agreed with, we were like, all three of those things, that's inside of our solution that we developed. Additionally, as we started looking at what would a timeline look like of the real world event if our solution has been in place, instead of seeing our ship burn for over 5 days and ultimately being lost, we would have seen it burn we would have seen the fire for 35 minutes and then ultimately extinguished, and we would not have lost a capital level ship. So that's why we came up with what our solution, Nimble, for damage control. That solution brings together the operational AI capabilities and digital twin capabilities in order to reduce the cognitive overload that any leader on a ship would have to something that's more manageable. Studies shown throughout the various research, because after the Bonnie, it was shown that captain had over 10,000 data points that he had to reason on in an hour. That's unmanageable for any given person. We've reduced that down to 4 to 5 data points per hour by implementing operational AI into our solution in order to give a common operational picture, surfacing the things that they need to focus on most all. Also, the technology that we built this on is already proven to work, already proven to be able to solve complex problems, where we're actually doing so within NASA as part of the NASA platform for autonomous systems. Within NASA, we're supporting them with actually putting autonomous operations onto satellites, where we're going to be autonomously controlling a CubeSat to go around the moon, as well as crew health and performance, where we're actively monitoring the health and performance of astronauts. Additionally, going back to the 80s, this this technology has been proven with supporting Iridium satellites and as well as platforms for oil and gas rigs. So now let's get into what operational AI is. As I stated, I'm prior enlisted Navy person, been on board USS Mahan, and the first thing that any sailor learns as they go on board a ship, even whenever they first go to boot camp, is that every sailor is a damage controlman. Every sailor must know how to fight fires. Whenever I got on board ship, when I got on board ship, we go through all of these qualifications. Even though my primary job isn't damage control, isn't firefighting, we go through all of these qualifications to work our way up to different positions. While I ultimately was it before I left the ship, I was able to get the team lead. It starts off with positions like boundary watch, nozzleman, and then team lead, and other positions that you're able to pick up within that repair locker. What does this have to do with operational AI? Well, it's having that domain specific knowledge in order to answer a complex problem that we see on board the ship. In the case that I just gave, I'm that human that's actually supporting the captain of knowing that his ship is protected and that when a fire occurs, it can be extinguished successfully. The purpose for AI, going back to its roots, was to find how software can think closer like a human, think more like a human. Over time, there's been more studies that went into the field where we started coming up with machine learning, deep learning, as well as generative AI, all different aspects of artificial intelligence that's leading to solving one ultimate goal. How do I give software the ability to think more like a human? In the case of the example that I just gave, as a nozzleman, if I'm entering in a fire in a birthing fire, I would have to be able to make the call. Do I take the team to the left or to the right in order to get closer to this fire and ultimately put it out? And after, I would have to justify that. As we looked at the way that artificial intelligence has progressed over the years, we're now getting to the same point where we have to be able to leverage artificial intelligence to have that domain specific knowledge and be able to have those explainable reasons on why it did a certain thing. That's where here at E3S we started implementing ways that we implement that domain specific knowledge expertise that focus on moving that generalized knowledge base to more of a focus domain specific knowledge that's going to help solve those problems. And while I'm using the example of damage control, it could be applied to other aspects as well, to include defense and intelligence, manufacturing and industrial, which spans across natural disasters for response, shipboard firefighting, global and national terrorism, as well as prognostic health management. Now, as I stated, the operational AI piece doesn't stand on its own. The other piece that goes along with this is also the digital twin portion. as we bring this together, the operational AI and digital twin together, here's an example of that CAD drawing within the ship. This is a pretty detailed drawing. You can see the various compartments, and if we were to zoom in and out within those compartments, you could even get down to seeing the piping. Now, as I mentioned, our digital twins actually go the next step further to not only giving you that digital representation, but the actual state that things are in. So if I was to zoom in on a AFFF piping, for example, which is a firefighting foam that's across the ship, I'm able to see which direction that foam is flowing, whether there's a valve that's in the shut position obstructing the AFFF from working in a part of a ship, or even see likewise for other components of that ship, such as the temperature and things that are going on within the ship itself. As we bring AI and digital twins together to operationalize it, one of the key factors is looking across the ship, looking across the assets and sensors that you actually have on board, to bring them into that digital twin so that you're able to reason on it and solve problems such as damage control and medical emergencies or command and control. So the next step, we're going to actually show you exactly what Nimble looks like, what the front end of that common operational picture looks like for Nimble. But before we get into that, I want to first give you an idea of what it is that you're about to see under the covers. As you look into the blue, as you look at what we have, Nimble itself is bringing together various models, whether it's AI models, digital twin models, reasoning models, or just the ability to schedule the taskings. The reason why Nimble focuses in on that is because we want to get to a point where we're reducing that cognitive load, meaning that we're reducing the reasoning that we have to take across various sensors, whether it's taking the output of the AI model and reasoning it with what we actually the state model of the digital twin, or scheduling certain events to happen. As we start to look at how we get to that for the domain-specific knowledge, through our Nimble Gateway, we bring in various sensors in order to be an input into Nimble and model against the AI and digital twin to ultimately come up with a reasoning purpose. So now I'm going to turn it over to Mark, our AI SME, in order to walk you through what Nimble is and how it works.
Good morning. My name is Mark Jones, and I have over 30 plus years of experience in advanced military real-time control system development, of which the last 10 years have focused on contextual and topological reasoning algorithms, along with artificial intelligence and machine learning neural network development. What you're seeing here on the screen is the basic layout of the UI. That is the front end view of the Nimble machine, which you saw in the laid out in the diagram that Carlton just showed you. Starting first, I'd like to look at the far right panel. What that is it's actually connected to the command and control network of the aircraft, and messages that are applicable to Nimble are being displayed there. What's also important about that is that those messages are going to be interpreted by the reasoning and inference engine and applied, if applicable, to the overall knowledge of the system. In the main panel at the top is the overall top view composite emergency event timeline. It's statically showing right now. Normally it would be moving in time, but I'm showing a static inference of it. There are 4 main events I've modeled. Event number 1 is event number 1 is a fire event. Event number 2 is a possible man overload. Event number 3 is an aircraft impact, and event number 4 is an injury. If you click on event number 1 and then click on the toggle timeline, you'll see that it explodes into the individual events that are occurring within that major event. It should be noted right now that there are 3 different types of events. The first one, which is red, is an emergency event. Yellow is a warning event, and green is a corrective action event. So starting from the top in time, we have 2 yellow events, which are indicating both temperature and infrared warnings that there is a temperature detected in compartment A39. As soon as that temperature raises above a threshold, which is going to be defined, it fires a fire event, which is the red event that you see there as the third event. After that, there's another yellow event, and the reason there is because the inference and reasoning engine has scanned all the other compartments around the fire and determined that just below there is ordnance being stored, and that is a concern. Obviously, you wouldn't want that to explode. So below those events in the green, we have the corrective action events, and the first one is event 5, and it is that the fire suppression system has been activated, and that fire suppression system is turned on not just for the room with the fire, but all rooms that the inference and reasoning engine have determined potentially could also catch fire. The next event is that the that's very small. Yeah, the next event is that the EOD disposal team has been activated, and also the fire team have been activated. And the last one, event 6, is that command and control. The CO, the XO, OOD, COB, and CDO are notified. Thus, all senior command and control officers and senior enlisted are notified by the ship's internal communication, but also Nimble is going to contact them through an application running on their cell phones. Over to the right, after the event has been extinguished, you have all of the events that Nimble knows needs to occur, like notifying command and control that the fire has been extinguished and deactivating all the teams that were activated to go fight the fire. With that said, moving back up. Moving too fast. Boy, am I moving too fast? Okay, event 8 is that we've notified all of the command and control infrastructure. After that, we should be going to the event 1002, fire extinguished. And then from there, we notify all command and control that the fire is extinguished, and also to note, it'll be sending those notices also to their cell phones. We're going to notify the explosive ordnance disposal team that they've been deactivated, and also the damage control team being deactivated. With this, now what we're going to do is go back up to the top view of the events by hitting the toggle timeline button.
Can we not control this?
No.
It's recorded.
And what we're going to go into now is event number 2, which is a possible man overboard event. So if we explode that event, we will see not a whole lot of information here. Basically that we've detected or Nimble has detected that a man is overboard. Now, how Nimble detects that man is overboard is that all the Navy crewmen will be wearing biometric wear that will detect, one, that they are in the sea, and 2, it also passes back the biometric data of that sailor. In other words, heart rate, CO2, temperature, criteria. And by that being fed back into our engine, Nimble is detecting that, a crewman has actually fallen overboard, has detected where on the ship that has occurred, since it knows exactly where all crewmen are on the ship at all times. It also fires from that all the necessary measures to address the fact that he's overboard. The next event, which is the aircraft impact event, I'm supposing an aircraft impact at the aft of the ship, where some of that aircraft debris is up on the flight deck, but a part of that debris has gone into the AIML below and caused a fire. And you will notice that Nimble correlates these two events in time and recognizes that the same event really has caused both of these conditions. That's why you see them both on the same display. Nimble will then go and create all the necessary corrective actions and notify all the command and control structure of the separate events. It will also send fire teams to both locations. As soon as the event is extinguished and dealt with, it will basically address those events. Bouncing back to the top, we go to the 4th event, which is a crewman has been injured. And it is surmised that someone has reported a crewman injury. And also Nimble has noticed biometric data to indicate that a crewman is in distress. It's also going to show on the display below exactly where it knows that crewman is at, so that those teams can be sent to that exact location. With that said, basically what we want to look at next is going to be the PLLM over on the left-hand side. The PLLM button stands for Private Large Language Model, which is very similar to ChatGPT, which is a buzz these days in all the news. It will be a private constructed large language model that will understand the overall functionality and activity of the ship. And it will allow a person at the operating station to enter textual information. It will interpret that textual information and give you responses. So you can ask of the system just about any question you can think of that's relevant to ship operations. In this case, it's saying, what is the status of my repair lockers? And the answer is repair locker 1, 3, and 5 manned and ready. Repair locker 2 is 60% manned. Repair locker 4 is 70% manned. During the last maintenance inspection cycle, 15 days, it's going to give you notes that it feels you need to also understand. Another example is if the fire was still ongoing, you could say, what is the containment status of the current fire? And the answer is the fire is currently 60% contained. Due to the fire's location and the increasing temperatures in the surrounding compartments, it is advisable to prepare a second fire team to be deployed to K39. According to the inventory, hazmat is stored in K39 and rising temperatures pose a risk of fire/explosion to the hazmat. Therefore, it is essential to immediately take immediate action and ensure that proper containment and response is applied. With that, I want to look at one more part, which is called the situational awareness map. And when you all of these events track internal to their data a latitude and a longitude, so that when you click on any event or sub-event, it's going to show on this map exactly where on the Earth that event occurred. And as I'm zooming in here, you'll see this is showing you exactly where the ship was when that event occurred. And if you were to click on other events, it would be moving because the ship is obviously moving or potentially moving through these events. The only time it will diverge from that is when you have a man overboard. It'll be showing two: one where the ship is, and also where the seaman is in the sea. And that concludes the demonstration of the UI front end of Nimble. Thank you very much for your time.